The biggest AI story of the week may not be coming from San Francisco. It may not be coming from OpenAI, Anthropic, Google, or XAI. Instead, it is coming from a Chinese startup called Moonshot AI. And the model at the center of all this attention is Kimi K3. Just a few days after its release, Kimi K3 started climbing benchmark rankings, flooding Chinese social media, attracting international developers, and forcing people in Silicon Valley to ask an uncomfortable question: has China just produced another DeepSeek moment? And this time, the answer may be even more complicated. Because Kimi K3 is not simply another chatbot that writes emails, summarizes documents, and answers trivia questions. Moonshot is presenting it as a frontier-level, open-weight system designed for long-running coding tasks, deep reasoning, professional knowledge work, visual understanding, and autonomous AI agents. According to Moonshot, Kimi K3 contains 2.8 trillion parameters, supports a context window of up to 1 million tokens, and is natively multimodal. That means it is designed to work with both text and visual information while processing enormous amounts of context in a single task. To put that 1 million token context window into perspective, we are talking about the ability to feed the model entire codebases, long collections of research papers, financial documents, technical manuals, or hundreds of pages of project history without constantly cutting everything into tiny pieces. But honestly, the context window is not the main reason Kimi K3 is getting so much attention. The real reason is that it appears to be combining three things that rarely arrive together: frontier-level performance, an open-weight strategy, and aggressive pricing. Moonshot says K3 is built for long-horizon coding. That phrase is important. Most AI coding demonstrations look impressive because the model creates a landing page, generates a simple application, or fixes one isolated bug. But real software engineering is much messier. The model has to inspect dozens or even thousands of files, understand how different components interact, run commands, examine errors, change its plan, test the result, and continue working without forgetting the original objective. That is what long horizon really means. It is not about writing one clever block of code. It is about remaining useful across an entire workflow. Moonshot is already integrating K3 into Kimi Code, its terminal and development assistant, where the AI can read and edit files, execute shell commands, search through a codebase, retrieve web content, and decide what action to take next based on the results it receives. And early benchmark results are exactly where the story became much bigger. Reuters reported that Arena ranked Kimi K3 first in an evaluation focused on front-end interface building. Val's AI reportedly placed it second overall, behind Anthropic Fable 5 but ahead of GPT 5.6 Sol. Artificial analysis also found its performance competitive with models such as GPT 5.5 and Claude Opus 4.8, particularly on complex, multi-step tasks. The co-founder of Arena even described the release as potentially one of the most significant model launches of the year, saying that further results could continue placing K3 near the top of the field. Now, we should be careful here. Benchmark results are not the same thing as real-world reliability. A model can perform extremely well on coding tests and still make frustrating mistakes inside a complicated production environment. It can generate a beautiful interface while introducing security problems, broken dependencies, or code that becomes impossible to maintain. But even with that warning, K3's early performance matters. A few years ago, many people in the American technology industry assumed that China would remain several months, or perhaps several years, behind the leading US AI laboratories. Export controls on advanced chips were supposed to make training frontier systems significantly more difficult. Instead, Chinese AI companies appear to be releasing stronger models at a faster pace. DeepSeek challenged assumptions about training efficiency. Alibaba's QW built a huge international developer community. ZAI pushed Chinese coding models closer to the frontier. And now, Moonshot is trying to demonstrate that a Chinese company can compete not only on price, but also on scale, coding ability, multimodal intelligence, and agentic execution. That is why Silicon Valley is paying attention. Kimi K3 does not need to defeat every American model on every benchmark to create pressure. It only needs to become good enough that developers start asking why they should pay much more for a closed model. Moonshot's official API pricing lists K3 at 20 yuan per M million input tokens and 100 yuan per M million output tokens, with cached input priced at 2 yen per M million tokens. The Associated Press reported that analysts estimated K3 could cost roughly half as much to use as OpenAI's GPT 5.6 Sol. That changes the conversation. Imagine that one model is slightly better, but another model delivers 90 or 95% of the useful performance at half the cost. For a casual user, the difference might not matter, but for a company processing billions of tokens, operating thousands of coding agents, or generating software around the clock, that price difference becomes enormous. AI competition is no longer just about who has the smartest model. It is becoming a competition over intelligence per dollar, intelligence per token, and intelligence per unit of computing power. And Kimi K3 arrived with enough momentum that Moonshot temporarily suspended new subscriptions after demand reportedly stretched its available computing capacity. Discussions about the model also reached the top of trending lists on Weibo, where users debated everything from model pricing to the future demand for AI infrastructure. There is an interesting paradox here. As AI models become more efficient, we might expect them to consume less computing power, but lower prices usually attract more users, and more capable agents perform longer tasks. Instead of answering one question, an agent might work for 30 minutes, launch dozens of tools, analyze thousands of files, and generate millions of tokens. So cheaper intelligence does not necessarily reduce the demand for computing. It could dramatically increase it. This may also explain why Kimi K3 is being positioned as more than a traditional language model. Moonshot promotes features for generating working websites, creating professional presentations, performing deep research, manipulating spreadsheets, and coordinating parallel AI workers. The company's previous Kimi models introduced an agent swarm system that could break a large problem into smaller tasks and send multiple specialized agents to work on them simultaneously. K3 appears to be pushing further in that direction, away from an AI that simply responds to prompts and toward an AI system that plans, delegates, uses tools, checks results, and continues until the job is finished. And I think this is the most important part of the Kimi K3 story. The AI race is no longer mainly about building the best chatbot. The next competition is about building the best digital worker. A chatbot waits for instructions. A digital worker receives a goal. A chatbot produces an answer. A digital worker produces an outcome. If K3 can reliably turn a product description into a functioning application, transform raw data into a polished presentation, investigate a technical problem, or operate across a codebase for hours, then it is competing in a much larger market than search or online conversation. However, there are still major reasons to remain skeptical. First, 2.8 trillion parameters sounds incredible, but total parameter count does not automatically tell us how intelligent or efficient a model is. In a mixture of experts' architecture, only part of the model may be activated for each token. Until Moonshot provides complete architectural and technical details, the headline number alone cannot tell us how much computation K3 actually uses during inference. Second, an open-weight model of this size is not something most people will run on a gaming computer. Reuters noted that operating a 2.8 trillion parameter system locally could require computing equipment costing hundreds of thousands of dollars. So although open weights give researchers and companies more control, K3 is not suddenly turning every laptop into a frontier AI data center. Third, we need more independent testing. We need to see how K3 performs on unfamiliar repositories, long-running agent tasks, cybersecurity evaluations, hallucination tests, multilingual work, and real business projects. We also need to know how often it gets stuck, how much human supervision it requires, and how quickly its operating cost grows when an agent performs thousands of steps. And then there is the geopolitical argument. American AI companies and politicians have accused several Chinese laboratories, including Moonshot, of using outputs from US models to accelerate their own development through unauthorized distillation. Anthropic has made such accusations directly, while Chinese officials have rejected broader claims of technological theft. Distillation itself is a standard training technique, but the controversy concerns how training outputs are obtained and whether they violate commercial terms or intellectual property protections. This debate will not disappear. In fact, the more competitive Chinese models become, the louder it will get. But there is also some irony here. American developers have used Chinese open models to build successful commercial products, while Chinese companies continue learning from research published by American laboratories. Modern AI development is simultaneously global, competitive, collaborative, and deeply political. Ideas travel across borders much faster than chips do. So, has Kimi K3 really shaken Silicon Valley? I think it has. But not because it has already proven itself to be the most intelligent model in the world. It has shaken Silicon Valley because it challenges the business model surrounding frontier intelligence. The leading US companies have spent enormous amounts of money building closed systems and charging premium prices for access. Kimi K3 suggests that models approaching that level could increasingly come from outside the United States, offer more control to developers, and cost considerably less to operate. That creates pricing pressure. It creates pressure to release models faster. It creates pressure to improve coding agents. And perhaps most importantly, it weakens the idea that only 3 or 4 American companies can participate at the frontier of AI. Kimi K3 of May eventually proved to be overhyped. Its benchmark advantage might shrink as more people test it. Its enormous scale may make deployment difficult. And the next model from OpenAI, Anthropic, Google, or AI could move the frontier again within weeks. That is how quickly this industry changes. But even if K3 does not remain at the top, the direction is becoming clear. China is no longer simply trying to catch up in artificial intelligence. Its companies are increasingly influencing model architecture, open weight development, agent design, token pricing, and the speed at which the entire industry is forced to move. DeepSeek showed that efficiency could disrupt the AI market. Kimi K3 is now testing whether open models can compete directly with the most capable closed systems, not just in laboratory benchmarks, but in the work people actually need to get done. And if that happens, the biggest winner may not be Moonshot AI, China, or Silicon Valley. The biggest winners could be developers and users, because the cost of advanced intelligence will keep falling, while the number of serious competitors keeps growing. The AI race has just become more global, more aggressive, and much harder to predict. And Kimi K3 of May be the clearest sign yet that the next major breakthrough does not have to come from Silicon Valley.